Am I audible to you all? We'll wait for couple more seconds so that people can join in as I'm gonna lock the meeting. So in case if you feel your friends haven't yet, request them to join as soon as possible because once I lock the meeting, I'm not going to unmute. So we'll wait for another few minutes and then we'll begin with your practical sessions. Okay, pretty well. Uh, Almost seems so many of you have joined. So we'll start with your session. Now, before moving on, uh, this is the syllabus part where it gives you the list of the practicals, and I'll tell you which all practicals we'll be taking up for your IoT, and accordingly we'll proceed ahead. So, out of which, if you could see the list, preparing your Raspberry Pi. I hope this size is fine. Let me increase a bit. The first practical is preparing the Raspberry Pi hardware for your installation. So, in that case, if you remember from your theory part, we have already covered up how to install and which all softwares will be required for formatting your SD card, installing your image, and other things. So then this part is already done in your theory. I'll be just going through these slides for a revision. Viva questions can be asked for this practical. This Linux commands exploring on your Raspberry Pi. Again, we have seen in your theory part where we had covered all the commands of your Linux and how they are differing on your Raspberry Pi. So even we have seen this particular part onto your theory. Even I had covered how to write a Python program and blink your LED. We have even seen SPI camera connections, images to capture using SPI, and we have even seen your Node-RED to connect LED to Internet of Things. These six practicals. Practical number one, I'm keeping the nomenclature, the numbering as per the syllabus: one, two, three, 5, and 8 are already taken in theory part. Those who have forgotten, just for them. So, in your theory part, if you see, this was where we had prepared your Raspberry Pi hardware and Raspberry Pi installation of your OS and preparing your hardware for the connection. This is your first practical. The second practical that was based on Linux command. We have seen the Linux command on your Raspberry Pi. Today I'll be just giving you the practical demonstration, but then we have covered this. In this Node.js introduction, I have given you the basic Node.js, how to connect it, how to view your new Node.js. This is where you had covered up your SPI for camera. So camera module also we have done. Fifth practical. Simple IoT LED program I had explained you over here. So if you see your practicals, list of your practicals which is being given by the university in this syllabus of your university, first practical, second, third we have covered up, fifth we have covered up, and eighth we have covered up via your theory itself. So initially I'll be executing and showing you the demonstration of this via PPT. Then I'll be shifting on to Raspberry Pi where I'll be showing you the execution of each and every. So out of 10, I'm trying to cover 7 months. So if you want to note it down, you can note it down. Practical 1, practical 2, practical 3, practical 4, practical 5, practical 8, and practical 10. These are the 7 practicals that we are going to study and which can be done via online session. The others will require your actual presence. So I'm not covering it up all. In this slot itself, we'll be covering first 5 practicals as listed in your syllabus, then 8th practical and the 10th practical. We are going to do it. So far everyone is okay. Now for notes and all, you'll everyone is aware you won't be we won't be providing you any ppts or pdfs. So in that, first I'll explain the whole practical, then I'll ask you to take the screenshots of that whole practical at once, because in middle if I go up and down in the screen for the explanation, then that flow won't be giving you the proper screenshots of one full practical. So I'll be completely explaining it to you, then I'll give you time for screenshots all at once, and then I'll be giving you the demos one by one after the other. So initially I'll be explaining you 2 3 practicals, then you'll be taking these screenshots, and then I'll be switching on to Raspberry Pi and showing you the demos. Is that flow okay with everyone? Cool. Let's begin with your first practical. Now, those who have attended, it will be easier, and I'll be rushing through the slides because this is depthly explained to you already. So this should not take any time for explanation. For installation and hardware preparation, what things I need to collect it, what things I require from the Raspberry Pi kit. I'll require these all 9 things from your Raspberry Pi. This is what we have seen how they are going to be connected. So your labelings refers to your each and every modules. So I'll be having a monitor, I'll be having an HDI cable, Ethernet card, I'll be connecting the USB and the keyboards, the power plugs, micro SD card initially will be connected in your reader. That card will be formatted using the SD card formatter. Once the SD card formatter is being used, the OS which is being downloaded from Raspberry Pi's site, it has been kept on extracted using one of the extractor, that is 7-zip default if you remember, and later on that SD card is being booted and made bootable with that ISO file which is present on the machine using Win32 disk imager application, and it is written onto the SD card. So SD card would contain your OS, which will be a bootable Raspberry Pi OS. The latest one is Buster, and demonstration will be given you on the Buster itself. Once that is loaded, you'll get the first screen of your desktop, which will look similar to this. So this is the Raspberry Pi screen, what you're viewing right now. This is how your Raspberry Pi looks like after booting it up for the first time. This is your desktop of your Raspberry Pi. So this is booted up, and how to bring that installation, these are the things. So you'll require SD card, you'll require a computer, you'll require a Raspberry Pi along with your peripherals. So the things needed or the requirement for first time booting up your Raspberry Pi are minimum these. This is what you had to go and download it from your Raspberry Pi, the latest one, whichever it is. We are downloading that particular, and we are recommending you the desktop and the recommended software. I hope everyone remembers there were 3 images, one with desktop, one with recommended software, and the light version. So the recent one which is there, this is the older version Stretch, and the recent one is Buster. So we are actually performing the Buster onto the sites. I hope you remember this. The recommended programs for extraction your zip files was this. Since we are using Windows machine, I'm using Windows, so we'll be using 7-zip software. For extraction, for writing down, for making the SD card bootable, we'll use Win32 disk imager software, which looks like something of this sort. So it accepts three things. One is the drive, that is SD card is connected to which USB drive. So once I connect the USB, it is asking, it gives you the drive name. The device name is automatically taken, that you can select it from here. Once the device is selected, click on this folder icon and give the path where your img file of the Raspberry Pi is being kept. So whichever OS you had downloaded, wherever it is kept, just give the path of that along with the file. Just select that file. Once you select that file, you have to supposed to click on the right. It will prompt you that whether you want to format the SD card and all, erase everything. Just accept that formatting. It will again format. So Win32 disk imager has its own internal formatting scheme also. So it will format that and it will move ahead. Once the progress bar has completed this, right on this dialog box, you will get a confirmation that it has been written completed. So detach your SD card nicely by right clicking on your SD card image and unplug it. Now put this SD card back into your Raspberry Pi slot. This is where you're going to put it up, your Raspberry Pi, the SD card behind this. So when I flip this particular, at the back I have the Raspberry Pi SD card slot. So I'll be plugging that slot in that particular available area for SD card. Once that slot is being put up, just connect your Raspberry Pi to your monitor along with the peripherals and switch on the power plug. The moment you switch on the power plug, it asks you your username and passwords. So this is the default username is Pi and the password is Raspberry. So if you see, I have been connected to this particular using Pi and Raspberry. So this is the default one which is being connected. And if you see, Raspberry Pi is the name of the machine. Pi is my user and the password that I had entered was Raspberry. Control Alt T will open up your terminal. Updating OS, I'll fire these commands for updating and upgrading it. So these all we have seen. In case if I have to install any of your applications, I need to use your install apt-get install and followed by your package name. So these are your updation and upgradation commands which will be required. So this we have seen, if you remember, along with your distribution and so on and so forth. Now the Raspberry Pi which I'm connected to this machine is already updated. So if I fire update and upgrade for this, your Ethernet has to be plugged in. So if you see my Ethernet or my Wi-Fi, either one has to be plugged in, and that you could see at the top. Can you see this? My Ethernet plug is giving me the IP address when I'm placing the mouse onto it as 192.168.137.27. That 27 is my host ID. This is what the IP address is. /24 is nothing but the IP's masking. So if I want to see only the IP address, this is one way of seeing it. And the other way is by this command, ifconfig. So ifconfig. ifconfig gives you the full details of your available options for connecting it to your internet. The wired one is ETH0, which stands for your Ethernet. So this is the information about your Ethernet, since I'm plugged in using Ethernet. In case if I'm plugged in using your wireless, turn Wi-Fi on and I can select my SSIDs, whichever are available in my near ones. So that I can select, and this wireless WLN0 is going to have its own IP address. Currently, I have two IP addresses of my internet. One is 192.168.137.27 is the IP address which is connected using Ethernet. Since I have plugged in a Ethernet cable, via that I'm able to connect this. And by default, if I'm not connected using Ethernet, I have the local IP address as 127.0.0.1, which is the local host IP address. Now check here, it gives you the full information. What is the mask? What is the broadcast address? What is the line LAN that is connected? How many packages are exchanged? How many packages are received? RX and TX and everything, full detail. It doesn't gives you only IP address. So IF config command gives you the full information about your network. In case if I want to see only the IP address of my machine, which is the external IP address. So the command is hostname -i. Check, I have got the same IP address, which is an Ethernet's IP address, a default one. So it gives you the only IP address if you're interested. So host name -i is the command which gives you the IP address of the machine, and it gives you only the IP address, nothing else. This is your application from where you have the installed software, as we have installed the recommended softwares as well. So Node-RED, Python's IDE Thorny is already installed. Along with that, you have your Office, that is LibreOffice. Full Linux is already installed. Internet has Chrome. In your graphics, you have viewer of your this few image Python games are also installed. You have accessories, terminals are over here. In the preferences, this is important. If you remember, there was a command called as raspi-config. So when you click on this, these were the options in which you have to go in your interface and whether which module is on or off, enabled or not. This was there. So if you are using camera module, you have to go and make the camera enabled. So this was the command which was giving you a non-GUI version. And in case if you want to see this particular same command using GUI, you have Raspberry configuration, and Raspberry configuration is present inside your application preferences Raspberry config. The moment you click on Raspberry config, you get a dialog box. Systems check. Raspberry Pi was the host name. I'm connected using desktop. Login as Pi along with the user. Display, you can change the resolutions. Interface gives you the same output on what the Raspberry config was giving you. Raspberry-config gives you a non-GUI version, whereas in Raspberry configuration interface tab gives you the GUI version. Camera, SSH, BNC. Defaultly, those are disabled. Now I have enabled for execution. So this is manually executed. Once I disable it, it will be disabled. Once I enable it, it will be enabled. Once I do that, I have to click on OK and reboot my machine. Localization tab gives you to set your time zones, keyboards, country, and so and so. Performance of your GPU and CPU. So these are your configurations of your Raspberry. This is fine. First practical, which is being booted, and this after booting, when you install, when you run, you're going to get this particular screen, the welcome screen. So if I reboot and show you, it will give you the same system installation. First practical, is it okay with everyone for the installation? Do you have any queries regarding this practical? Does someone wants to speak? Because they are unmuting themselves again and again. And if I find people unmuting themselves, maybe I'll have to dismiss them and I won't allow you. If you have any queries, you can post it in the chat panel. If no, then I'll proceed on to the second practical. Yes, Justin, I do have a Raspberry Pi, and the screen that I'm showing you right now. Just a minute, let me switch. This is actually a Raspberry Pi connector. I am connected to Raspberry Pi. Okay, give me a second. Yes, Samir Bishit, what's wrong with you? Do you want to speak anything? Want to conduct the practicals? Not only Samir, the others also be careful. Can you see the Raspberry Pi right now? So I'm basically actually connected to Raspberry Pi via the Ethernet cable. So this is your Ethernet cable which is connected. I have an HDMI cable. Just turning the slot just to show you SD card. This is where the SD card is punched in. So this is your Raspberry Pi. Now this is actually connected and I'm sharing that screen through my, there are few queries. I'll address those queries. This is actually I'm performing. I'm connected to my Raspberry Pi and I'm showing you the live demos. So there are few queries. Let me address them. Nivedita is asking, ma'am, but when we have this Raspberry Pi chip, then we'll be able to perform the. Uh, I hope your practical sessions have been conducted, right? The practical sessions for other courses are already on. So practicals for Raspberry Pi, yes, until unless you do not have Raspberry Pi chip, you cannot perform. You have even seen what is the size of your Raspberry Pi. I have told you that Raspberry Pi chip, the motherboard itself is the size of your SD card. Now I have shown you physically. When I was holding it in my hand, it was completely fitting into my small hands also. And the chip slots and every connectors I have shown you physically. Yes, until unless you do not have Raspberry Pi chip, you cannot perform this because it is an ARM architecture and your laptops doesn't has ARM architecture so far. Until unless you have a specialized ARM motherboard which is in present in your laptops. The recent ones are coming along with that. The other thing is for exams what are conducted at over this place, it is only Viva questions. So based on verbal interaction, which softwares for examples are used for formatting, so you need to list them or explain these steps for execution or for explain these steps for installing the Raspberry Pi and making it ready. So you need to tell me these steps. Step one is to go and download the Raspbian from so and so website. Second is to unzip that file using any of your recommended programs. Here we are using Windows 7, so we'll take up 7-zip. Third is to write that onto your SD card. So such kind of things you're going to explain and the flow. Whereas in second practical, which is conduct will be conducted based on your Linux commands, I may ask you to type down those Linux commands into your chat panel. So then this is how your Vivas are going to be conducted. Yes, obviously you don't have Raspberry Pi. I know that, and I don't want you to purchase right now also. So those who really want to purchase at your space, you can purchase it. But then I won't force anyone. There is no need because if you're not interested, there is really no need for purchasing it. In case if you want to perform the practicals at home, you need to purchase the Raspberry Pi kit. And Raspberry Pi kit, the recent one, the one which I have shown you is 3B model, and the recent one available is 4A model. So if you want to purchase, around 3500, 3500 is the cost along with your basic LEDs and all those. Else if you want to just purchase only the kit, the Raspberry Pi without the minimum connectors like LEDs, male female jump wires, breadboards, and all those, camera module and all, then the cost goes to 2000, 2500. So this is what it is. Around 4000 you'll get everything. I hope Nivedita have answered your queries. Any other? Okay, for first practical, I have completed. So let me move on to your second practical. And once I complete few, and then I'll give you a space for performing your screenshots. So now in this practical, it is completely Linux commands, and everyone is familiar to your Linux commands. I won't be executing the Linux command again and again over here. Now this is the basic connectors. For switching on, I'll have the Control Alt T. For creation and all knowing your terminal, we know we have done this. So if the current working directory, ls, ls/t, and all these are known to you. So such kind of commands will be there. I may ask you such kind of things. If I have a long listing, I want to write a command to display the long listing of configuration files. So the command you will have to write down in a chat panel will be ls space hyphen l slash space slash etc. So this will give you the configuration files information. So these are your basic commands. Along with this, we have even seen you how to create your directories, how to change the directory, how to remove the directory, how to copy from one position to the other the folders and the directories. These all we have seen. mkdir, cd commands, then mortis tilde, then file management commands, how to create a file using nano, how to create a file using leaf pads, editors. So if I have created these files and the content is being placed, how to have a grep search, reverse, cat commands, tag commands, how your echo commands are going to work with your hyphen e. We have seen all these. Head, tail, cp command, copy commands, recursive copies, move from one place to another, mv command, grep command for the search, rm command for the removing. If I have to type down this content and make this file executable, a shell command, how would I do? So using nano, I'll have to do all this. To make it executable, I'll have to convert this using your bash. So if this is there, then we have even seen the listing effects. What was standing for what, how we'll make the executable command by changing your modes into a readable format, providing the file permission access. This table was shown to you octal state. 777 was giving you the full access, how to change the mode, how to give the ownerships. Tree command was giving you the full structure hierarchical tree. Then we have even seen the hardware commands, CPU/CPU info. It will give you the full information, memory information. This was specific to your Raspberry Pi. This I'll be showing you the outputs of them. But then before going ahead with this, till this slide, does anyone wants to see the output of any of the commands? Because this is similar to your Linux. So I don't think so that will be required. But then in case if you feel any one of you that yes, you want to see the commands output onto Raspberry Pi, you can ask me. Else further slides, what I'm going to show you the outputs because those you haven't executed onto Linux. So till this slide, does anyone wants to see any of your outputs onto Raspberry Pi? Or if you have forgotten and you want to know what will be the output, how it will look like. No, that means everything is understood. Outputs are there. No one want me to execute any of the commands, right? Okay, I have the recording anyways. So if anyone feels yes, you require the outputs to be viewed, please feel free to put up on the panel, in the chat panel, I'll definitely answer it. Don't think that others are not asking, so how they'll feel like. If you feel that you want to see the output, put it up. And it is not hard and fast rule, but it is almost similar, exactly, in fact, not almost, exactly similar to your Linux. Priyanka Ray, which one you want to execute? Prashant, show what you want to see. Which commands output you want to see? You want me to show each and every 32 commands? You want me to show 32 commands? View it. I have ls command. It is giving me the list. Ls minus L gives you the detailed list. Check the two different pies are there. Both of them are pi and pi. So the owner is also pi and the creator is also pi because I have logged in as pi. So hence it is this. If I change, I can change it to root directory cd uscs tab. I am inside this. So pwd, this is where the path is. If I say cd tilde, I'm back to this. Pwd gives me the current working directory. Tilde is nothing but my slash home slash file. I'll change the background in case if it's problematic. I hope now this is visible. ls command or size. Pretty much good. Dave, hold on, screenshot for the commands. I'll give you the screenshot of the PPTs. You can take it up. Here, this also screenshots if you want, you can take it up. So wherever you feel that you require screenshots, ask me, ma'am, wait, or I'll be pausing, or anyways, I'm giving an explanation, so I'll be taking up few seconds, few minutes to explain. By that time, you can take up the screenshots. ls, now check, this was not human readable format. So 4096 is bytes. In case if you want human readable format, so I have to append H option. So it gives you the human readable format. Check 4K, 4K kilobytes, KBs. In case if any hidden files are there, it will give you with A. Check the same listing I'm showing you. ls minus L gives you only this much output. Total is 40, but it is not giving you 40. ls minus la is giving you the hidden files also. Check you have hidden files dot slash node-red dot pm dot public profiles dot configs and so on and so forth. Similarly, ls minus l slash etc was giving you all the configuration files. So this is your config files dot conf. Wherever you see the all the configuration files, your sudos, your outputs of your other username and passwords are also even stored over here. Your shadow files are being put up over here. In case if you want to view any content of any file, say suppose I have this folder, let me create one file. So this contains these Python codes which I have put up. These are my codes written. So I'm creating a file, and say suppose using echo command, we are creating this file. So this will be printed as it is. Check wherever I have written down the /ins, /t's and spaces, it is giving you that way the outputs. In case if I redirect to this a file, say file name I'm giving you so I've redirected to the file. Check test.txt is created right now. Cat test.txt, it gives you the same output. So this is how your files are created. This is using your echo command. As it is created. In case if I want to create using nano, I can create that. Say suppose I'm purposefully giving this so that will be easier for me for the next step. I'm inside now nano editor. Check the name of the file is now test1.txt. This is same as your notepads, but then this is command notepad and not the GUI. It is your non-GUI version. Some content in the file. So to come out and save the content, I have to press Control X. You can see at the bottom you have Control X which says. So I'm pressing Control X to come out of the file. The moment I press Control X, check this content now is in buffer. It is asking me, do you want to write this content to this particular file? Yes or no. I'm pressing Y. The moment I press Y, it is asking me, do you want to keep the name as same or do you want to overwrite? I'm pressing just enter. I want to keep the name same. So test one is now created, and if I say ls, it is having some content. Ls minus l will give you the size of the file and when it was created 1st December at 1:55. So check now it is root and root because I have created using sudo command. So sudo has created it as root. So root user has created it and not the pi. So this is where I can change the username, the creator and the executors. This is fine. If you see cat test1, it gives you the same content of the file, the output of the file. Head -1 test1.txt first line. Tail -2 test1.txt bottom two lines. So this is how your outputs of your file is. If I say tree, check it is giving you the tree. Now since I am inside USCS 306, it has these files. It is giving you a tree hierarchy. In case if I and now I do tree after creating two directories, dir1 and dir2 is inside dir1. Check I have directory 1 inside that directory 2. So being over here, I can even fire move command. I'm moving test one.txt to check the permission is denied. This is because I haven't inserted sudo commands. So this is moved. Now check test1 should not be there in this list. Check test1 is moved now. It is should be present inside your dir1 now. So test 1 is not there. cd dir1 and I do tree or ls, it gives you the test file. Check. So this is how you can move and rename the files and so on and so forth. This is okay. The basic commands. The query is there from Prahlad saying that Prahlad Shukla, ma'am, can we run Raspberry Pi OS without Raspberry Pi chip installing it on Raspberry Pi? On VirtualBox, yes, as you have asked, Raspberry Pi VirtualBox OS you can implement. So this you can execute. So you can download that image which I have told you from that particular website. You can configure that onto your VirtualBox. You can run that. You can get this kind of working, but then you cannot get those GPIO pins. Now let me show you what I want. Now, in this, moving back to your PPT first. Now, this were your basic commands. Now, there are some hardware information. Now, that hardware is only, now whatever information I'm showing you by execution of those commands, those are the outputs of your Raspberry Pi chip and not of the laptop on which I'm connected. Let me make sure I'm connected. My Raspberry Pi is connected onto the laptop screen. So the dashboard, what I am viewing is sharing via your HDMI's, and the screen display screen is the laptop screen. But then the content that I'm executing, whatever the folders and the files I have created, it is not on my desktop. This is my PC. It is not anywhere on this particular folders and all. If I open and show you, nothing is there within this. It is not in these files. It is completely empty. Neither it is there on the desktop and nothing of that sort. So whatever I have shown you, it is onto your Raspberry Pi chip through which I have shown you the switch on the camera and I have shown you the Raspberry Pi module. It is actually onto the Raspberry Pi. And the information of the hardware that I'm going to show you, that is also on the Raspberry Pi. So you can execute the programs, but then the output that I'll be showing you onto your LEDs and GPIO pins and all, you won't be able to see that. Basic OS practicals, this practical you can perform onto your VirtualBox in case if you want to install Raspberry Pi OS using your VirtualBoxes. Display the information of the Raspberry Pi, CPU information and all those. I'll be showing you this CPU information which I'll be showing you will be of the Raspberry Pi and not the CPU information of my laptop. Memory information of the Raspberry Pi. Version of Raspberry Pi. Temperature, because temperature sensor is there. Now this command you cannot fire on your VirtualBox. When you'll be firing this command, also they'll be giving you the outputs of your laptops or desktops of your VirtualBox on which you have installed the OS. Here when I'll be running these commands, this will be of Raspberry Pi. Prahlad Shukla, is it clear? And the others also. The question of Prahlad was, can I install the Raspberry Pi OS using VirtualBox onto my laptops or my desktops? Yes, you can install it, but then when these outputs are there, these outputs will be the outputs of your machine, that is your laptop or desktop on which you had installed the OS. The output what I am going to show you for these commands will be of actually that Raspberry Pi kit. And vc gen command, measure underscore temperature, this command would not be supported by your laptops or desktops, as this requires your temperature sensor. This is in present inbuilt to your chip. So it will give me the temperature. I'll show you the temperature of the Raspberry Pi kit right now. Is it okay? The commands are fine. I'll be running these commands one by one. CPU info, 4 hardware commands, CPU info, memory info, version, and the temperature. Check, it has given me the CPU's information. Full CPU's information has been displayed over here. I have four cores as I have taught you the architecture in your theory. So the first core is the zeroth core, the original one, which is the default one, ARM 4 processor. Fourth revision of that has been used. CPU's memories and all those have been displayed over here. The information, the first processor's information, the second processor's information, from where it is starting, what is the revision of the CPU, the full information about your CPU. It has four processors, so all four processors information is being displayed over here. Check the hardware chip. It is BCM2835 Broadcom's call chip, Qualcomm. If you remember, as I said, I mentioned I'm using the third model, B version, 3B model. So it is this. So the serial key of this particular is this. As you have the chassis engine number of any vehicle, the registration number, so every information about your CPU information is being present over here with this command. Similarly, now I'm firing memory information. It is giving you the full memories information. Total memory in KBs. Since I'm using 16 GB's card, so based on that, what is free, what is active, what is how much is inactive, what are dirty bytes, what is swap area, what is total things, and all that bifurcation of your full memory is being given over here. Output of these two is clear. So whatever output you have seen is not of the laptop, it is of Raspberry chip. So this outputs, you what you will be seeing through your virtual box will be of your machine, not of the Raspberry Pi, as you haven't connected. Let's see your these two commands, version and measure temperature. Check Linux version. This has been put up. We are using a GCC version of Ubuntu based by default, which is a Ubuntu's itself. And this OS was being downloaded on 22nd of October 2020 at this time. So I had downloaded the image version on this date, the updated one, and the recent one, which is Burster. VC gen command space measure underscore temperature. It gives you the temperature. Temp equals to 42.9. Instead of degree, they have put up apostrophe C. C stands for Celsius. So check the temperature of Raspberry Pi chip, the CPU. It is giving you that hardware temperature, not the room temperature. No? This is of the device. So the output of Zen command is okay. If you remember in your theory, we have even taken up other gen commands. Remember? Now these are your updation commands which I have shown you. Now this will take time, so I won't execute and show because this will take 1 or 2 hours depending upon the index repositories for the updations. Let me show you the let me create a file using your cat command. check, I'm trying to search the keyword apple in fruits.txt. Check, it is case sensitive. So inside pineapple, it was having this. So hence it has given me this particular output. When it is going to find this in both apple and pineapple, it is going to get the same thing. Hence it is giving me this particular. So this is how your grep command works, the search command. In case if I want to redirect this output of the grep into some other file, sorry, so I have the apple file which is created, and the output of the apple file would be apple and pineapple. So I have redirected the outputs of search to this particular thing. Is it okay? WC will give you the count of the file. It gives you the number of lines, number of words, and number of characters. I have two words, I have two lines, so two lines. I have two words, apple and pineapple, 16 characters, 5 characters from this, and 9 characters from this, and the name of the file. So WC gives you the count of the file, the full count, word count. If I say WC fruits, it will give me the full count of fruits. I have 6 lines, 1, 2, 3, 4, 5, 6. 5 words, 1, 2, 3, 4, 5, and 37 characters. Is it clear? These are your basic ones. Networking commands, I have shown you. ifconfig gives you the full information about your IP addresses. So if I say ifconfig and I want to know only the details of Ethernet, so I'll have to specify the name of the interface. So it will going to give me the only information about the Ethernet and not rest. If I say ping 127.0.0.1, my local host, it gives you the information whether that particular host is listening to that particular name or not. So it gives you at the end, when you break, how many packets are being transmitted, how many packets are received, is there any packet loss, and so on and so forth. If I want to ping, I can even ping on to the domain once if you're connected using the machines. So check, I'm pinging on to your external. This is internal to your machine itself, and this is to your external. So the IP address is automatically taken. And once I break it, if assuming there is a network problem, so it would have lost few of your packets. Then we have even seen the name of the host is Raspberry Pi. I have shown you this in your configuration also. Check, this is how you can confirm in your prompt also. You have Raspberry Pi, one confirmation, the other confirmation I have shown you from Raspberry Pi configuration. In the system, check the host name is Raspberry Pi. So we have displayed that. Host name -I gives you only, capital I gives you only the IP address of the machine. So these were your networking commands. This is your system configuration commands. Update won't take up so much long, so I'm just showing you the update. Upgrades, I'll be showing it to you, but then I won't confirm that upgrades. The reason is, if I confirm, it may take 2 or 3 hours for installation based on how many packages are not being installed onto my machine. So if recent updates and upgrades are not done, this may take time. So this is how you fire your updates and upgrades. Now when I install this, you can check it is calculating and only 2 are not upgraded. If I accept it, it is going to install that. Since I have recently configured it, it's recently updated, hence it is showing you, it is showing you the libraries also. I'm pressing N, I'm not confirming it, so it has aborted. So when you click on, when you type yes and it move ahead, it is going to go ahead. Same way I have shown you sudo raspi, how your configurations are going to be there. This is same. System options is going to give you the same wireless and host name and all those information. Display options in case if you want to change any resolutions. Interface options in case if you want to connect any extra peripheral connectors, commands, cameras. So when you click on camera, by default now it is enabled. If you want to disable, click on no, select no using your tabs, else press enter or escape. Escape for not changing it, enter for changing it, enabling and disabling. Check, I haven't changed it, I'm pressing escape, hence it is showing me this. Performance option, localization options, time zone, keyboard, and changing of your locales. The same thing you have seen. Similarly, you have advanced options also. In the advanced options, the drivers of GPL and the networking proxies, if you want to set all those configurations. And update tool is same as your update command. Check again, the update command is getting fired, which I had fired over here. The same output you're going to get. Once the update commands get back, I'm back to my screen. When I go on to your next by pressing tab, I'm finishing it and I'm out of the prompt. Check. This is how you come out. This is same as the GUI over here. Then even I have shown you the systems information commands, memory info, cat slash proc slash partitions. This is going to give you the partitions of your RAMs of your Raspberry Pi. So check how many partitions does your RAM has, default ones. The version of Raspberry Pi, if you want to see, you have this. Similarly, what is free, it will give you the free size of your memory. What is, how much is free, how much is used, and so on and so forth. VC gen command, one I have shown you using measure temperature. The other is which version of Broadcoms we are using, so which release we are using, and is it a GUI supportive or not. That other information is being displayed over here. Similarly, in case if you want to see the information of CPU and GPU, so you have vgen command, get memories information of CPU. So CPU is 0M, same way as for GPU. Check, I have said you that GPU is the one who works on your Raspberry Pi rather than CPU. Until a CPU is not required, everything will be done by your GPU. So currently whatever I'm executing, it is executed by your GPU. Hence GPU is showing you 128 megabytes. Similarly, on which resolution I'm connected, that is the screen, my information about my display screen, the laptop screen, get underscore LCD underscore info is the command. So this is the resolution on which I am working. This also could be seen from this. Sorry. Uh, check 128 GPU memory was being used. Display information about this resolution 1280 cross 720 24-bit megapixel is being used. So 1280 cross 720, these resolutions. 16 is to 9 is nothing but the resolution ratio that has been used. So it gives you through the commands. This command, cat slash proc slash device hyphen tree slash model, gives you the information about your Raspberry Pi 3 model revision 1.2. So we are using this particular Raspberry Pi, the physical hardware information. Similarly, in case if you want to see the other information like GPIO units, if you remember, I have shown you each and every diagram of your pinouts. That means how the pins will look like onto your Raspberry Pi kit. Where is the slot for Ethernet? Where is the slot for USB and so on and so forth. So I'll just scroll up. Check, this is your diagram which has been The moment I type pin out, it is giving you, these are nothing but your GPIO pins, 40 pins. So one starts from your odd and even. If you remember, inside your Raspberry Pi, it is one. Outside your Raspberry Pi, it is odd. So one, two, three, four, and so on and so forth. You have 40 pin diagram. You have four USBs connected. Ethernet net is connected over here. You have AV module over here. Power is here. Display module is here. SoC is chip is put up over here. HDMI cable is here. Camera slot module is over here. It is third B version of Pi. Revision is so and so. SoC is this, the name of this SoC, the number BCM2837. Tomorrow, if you go and purchase the latest model 4, this will be changed. The RAM is 1024 MB. I'm using storage as micro SD. 4 USB slots are there. One Ethernet port is there. Wi-Fi is enabled and Bluetooth is enabled. Camera is one slot. Display port is one slot. Each and every GPIO pin, check one pin, power voltage. Do you remember these? Physical pin numbering and logical pin numbering. GND, wherever you're seeing, are your ground pins. Pin number 6, pin number 14, 20, 30, 34, 39, 25, and 9. This we have seen in your connection of your LEDs. Remember? So with pin out command, you can get every reference of the modules, what you are using. This is clear? So this was your second practical. Of commands. Reboot and shutdown are the same one. I'm not doing that. This also I have shown you. First two are okay. First two practicals. Okay. The next practical source code I have already shown to you. So I'll just quickly brush up to show you the execution of your LED. Now this is how I'll be connecting my pinouts. The source code I have already explained, so I'm not revising the source code again. This will be executed and it will be present. Once if I connect my circuit using the breadboard connection, the LED will physically glow onto my screen. So let me quickly show you the execution. Now with this, if you see my source code, I have switched on the Python's IDE. So Python's IDE is giving me to open the branches. It is giving you the GUI shell is over here itself. In the right side, you can see the variable panel will be created. I'm just trying to load the file which is already present over here, and it is 8 program of your LED. The GPIO is connected. I'm connecting it to your pin. This is a code which I had already explained. Now in this, I have connected the physical LED to your LED. The moment LED will glow, it will is going to print on your shell also. So the moment you see print on, print off, print on, print off, at that time the actual LED is getting blinked in real. So check LED on, LED off, LED on, wait for 2 seconds, LED off, and then wait for 1 second. So off is quick, whereas an on is taking time because 2 seconds I'm waiting for LED to be on and LED to be off. So when I connect this particular physical to your machine, it is automatically going to get connected and I'm going to see the
LEDs getting blinked. So the program is as it is explained in your Python. This you can execute onto your machine, but then only see to it your GPIO libraries are installed onto your Python. You'll get the same output, but then only the LED part you won't get be blinking because you don't have that Raspberry Pi module. So if you remember, I shown you the video of blinking of your LEDs in your theory lectures. That is actually being blinking onto my Raspberry Pi. I need to connect my breadboard and you will be able to see the outputs. So this also I had explained it. Now let me connect the camera module. I don't think so. I have installed the. Okay, before moving on to fourth practical, let me show you the output of fifth practical, which is camera, which you have already done. So camera module once I connected, and this is how I'll be connecting it, and my camera module is enabled. If it is unable, I require a reboot. This is how you're going to connect your Raspberry Pi steps of camera. For taking up your still images, you require this. Now, since my Raspberry Pi is not connected to the camera physically, let me give me few seconds. I'll connect it, and then you can see the images how to click.
So the Raspberry Pi is getting rebooted. It will take little bit time. I'll get back to this screen. Okay. Check. I was saying that the moment I log into my GUI, I require the username and password to be given. Who wants to speak? So in the first practical after installation, I said I'll be logging as username and password. So check username is pi and the default Raspberry is the IP, the name. The moment I come, I get a login screen and a welcome message. Now, since I have logged in earlier also, so I'm not going to get a welcome screen. This is how after booting you'll require. It will give you an enabling information. So in this case, I have logged in. Let me check the LED is getting blinked or not because the intensity of the LED is too low now. Okay, still the LED intention is very low. Check this is when the camera doesn't get properly booted, you need to reboot your machines, and this takes time. So hence, this is only the issue when the modules are not connected properly. You may face a problem. So this will take again the time. By that time, I'll move ahead with the other part. Was trying to show you the output of this, but then this is very light, so via transmission you may not be able to see the glowing of your LED. But then I have already shown you a recorded video. So these are your commands for Raspberry still. You can fire this command sudo Raspberry still hyphen o space the path and the name of the image, and I'll be able to get the things. So this is the program which I also explained in your theory. Was trying to execute this. Before execution, I was checking the still images if it could be taken up using the command. So with command and the program, you can connect your Raspberry module and get the information. This is for your capturing, for recording your videos. Start recording. So this program has already been explained to you, and output also I have shown you via your still images in your theory. The rebooting of disabling is done. Now again I'll have to enable the camera so that my camera is set up. and I can view the take the click the pictures and run the program. So after enabling, again it will go in the reboot mode. This is what the preferences are to be set. Every time you need to set up this in case if you have any issues with the connections. So let this get rebooted. By that time, you can take up the screenshots. So far I have executed and shown you first practical, second commands practical, third LEDs, and fifth cameras. I would like to show the Node-RED as well right now itself, and Raspberry Pi web camera. I have explained it to you. In case if I get time, I'll be showing you the output. Else, probably the outputs images I have already shown you how the images will look like when the images are being clicked. This I'll directly show you the connectors and performance, as well as this simple HTML page. Before that, you can take up the screenshots if you want for any practicals. The first practical, I'll wait for 2 seconds, um 5 seconds, 1 minute across, and that much time should be sufficient for taking up your screenshots. The reason it is getting sharing screen is disabled because I'm trying to restart your Raspberry Pi, hence it is getting interrupted. So just a moment. You can start taking the screenshots for the first practical. That where your was your first practical. I hope everyone has taken these screenshots. Okay. The second practical, that was your Linux commands. You can start taking up for the Linux commands. Note that the output of fifth command, that is this, is one single line. Now, since it is a PPT and the size, I have increased just font size to be displayed nicely. Hence, it is on spread on three lines, but then actually it is one single line. So this was your practical 2 Linux commands. Has everyone taken it, all these screenshots? Now check, these were your sample codes, not necessary the same commands I'm going to ask you in the exam. So these are just the samples. And for this Linux commands, I may ask you to type down in your chat panels the commands, only the commands, or maybe one or the other line of one of the programs. Say, for example, this third program, when I will be taking up the screenshot of the source code, I may ask you any one line to be typed or the syntax of some command and so forth. So you can take these, start taking these screenshots for third practical, that is blinking of your LED. Which are highlighted in this block are nothing but the extra components, whatever is needed in practical 1 and 2, that is constant for every practical. Extra things will be blocked up. This for your reference, if you want to take, you can take, but then this is just for your explanation. What is GPIO board and GPIO BCM? It is not the part of the practical, just for your information. This is your program, it starts from here. So I may ask you to type down the library that is required for sleep method. So you have to type down from space time space import space sleep in the chat panel. So this is how not the only questions which will be asked. These are your sample questions, what I'm just demonstrating over here. The vivas. For this Python code, I would suggest you, everyone has your machines, if you are at your home and Python is installed on Windows also, just type down this codes to get the flow of your codes. Wherever you see the GPIO statements, that you can comment it, the print statements you can keep it as it is. Instead of this GPIO, you can just have a print statement. LED will be false, cleanup of your LEDs connecting to high voltage, so print one and so forth. So you can view the partial outputs. You won't be able to the screenshot of this, because the other ones were just explanation of your components. Circuit connections are important, so this is the part of your practical. The ones which I have quickly slided down is just for your explanations, how the components looks like. I hope the third practical screenshots everyone has taken. Okay. The fourth practical, that is 8 cross 8 LED. If you remember, this output also have shown you how the blinking of your scrolling of your text is done onto your 8 cross 8 LED along with your blinking of your LEDs. You remember the text was getting scrolled. You take the screenshots of this practical, fourth practical. This is your 8 cross 8 board which is connected to Max 7219. If you see, there is the name written on this particular IC. It is not clear, but then still you could make out something is written on this particular panel over here. So this is Max 7219, which is written over here, that IC chip, and these are connected. And check, these are your connectors. So connect VC, ground, input, chip select, and clock synchronization of 5 consecutive wires. Internally, this is the diagram, the circuit diagram, how your resistors are connected, how your capacitors, rows, and columns are connected, 8 cross 8. So a matrix is already been built up within this. And this is incorporated. If I have to print A, check, this LED row gets blinked up, only this is not there. So you could make it out, this is your A. Starting from here, this is glowing, then this is glowing, the next row is glowing fully, and then these two lines are glowing. So whatever red dots you see are nothing but your LEDs of your 8 cross 8 will be blinked, and that is your matrix getting formed automatically by that 7219 max. Max 7219 reads, when you type A, which bit is to be 0, which bit is to be 1 automatically, and based on that it prints that character and gets scrolled. For that we have written the Python program. I'll show it to you. In that case, you're connecting that 5 wires. It is a joint wire which is called SPI cable. So we need an SPI cable connector which should be enabled. So SPI module should be enabled. We have seen what was serial peripheral interface module. This is seen in your preferences Raspberry configuration. Within the interface tab, I have to switch on my SPI cable. The 7219 is present inside your Luma directory. I have to make sure that Luma library of Python is installed. This is the library. If it is not installed, I need to install it externally by firing this command. Now, this library imports uses the SPI cable connector. After connecting the SPI cable, I need to formulate the component of the device. I have to configure so that that matrix is automatically being configured by the SPI module itself. For that, we'll require the second import statement, that is matrix.device import max7219. To display the message, I require show message which is present inside luma.co.legacy. Now check, when I was installing, I had installed full Luma directory. The moment I install full Luma directory, automatically the subdirectories are getting installed. And how that font is going to be displayed on your LED, I'm trying to display the LCD's font. So for that, we are going to get the font name. So we require some font and the type of font, how it is getting displayed. The libraries are fine. Now check this line. When I'm trying to create the object of SPI. SPI requires on which port number you're connected. By default, it is single device, so we are connected on 0 port number. Similar to your arrays, indexing is starting from your 0 device. I'm giving the original initializations of your device as 0. GPIO no means no operations. That means there is no initialization. Whatever is your default initializations, automatically those should be set using these parameters, these three parameters: port as 0, device as 0, and GPIO as no operations. I'm creating calling a constructor of SPI. For this line, the first library which is there is being called, that is luma.co.interface.serial. Similarly, for creating the device, I require the object of serial. So in that case, I have the next statement: call to the device, creating the object of device max 7219 library, which is importing this object serial. So whatever is the configuration of serial, now the device is connected. Now once the device is connected using the pins onto your GPIO, I need to display the message. For displaying the message, I require the method called as show message. So I'm giving a call to the show message. Show message takes up your 5 parameters. The first parameter is the device to which you are connected. That is this. I'm connecting using max 7219, the serial port. So then the configuration of that device is the first on which you want to display. So that is the first parameter. The second parameter is the text, the content that you want to display. I want to display Raspberry Pi. Now this Raspberry Pi, I want to fill it in one color. Now since we are using monochrome, so if you provide any color LED, it is going to be having the same single color because it is monochrome. In case if you have 8 cross 8 LED which is multi-chrome, so whichever color you specify in this, if it is white, red, yellow, blue, whichever standard colors you type down as a string, those colors it will be printed. But then in actual practicals, the video that I have shown you during your theory, it is going to print only in red because we are using a red color monochrome 8 cross 8 LED. So this is, though I have put up white, it is going to wave off because white color it doesn't exist. It is monochrome, single chrome. Font proposition, I'm making it as font of LCD font. Hence that last line of import statement was used. Finally, how much delay in scroll? Rotation. If it is getting scrolled, relayed, so some delay has to be given so that I can view RASPBERRY space pi. So then the content that is displayed, that is getting displayed after 0.08 seconds. So at this much seconds it is going to be displaying. So 8 milliseconds. So that it is scrolling is fast. If you increase the delay, you'll see the slow speed. If you decrease the delay, you're going to get fast speed, inversely proportional. These 4 pins which you are seeing on your 8 cross 8 LEDs, physical pin numbers, you're going to connect it on these 2, 6, 19, 24, and 23 respectively. You can see the connections. All these connections are connected using one single SPI connector, which is a bunch of 5 wires together. So all wires are connected accordingly to view the outputs. You can take the screenshot of the program. This is right from here. You can take you can even take the screenshot followed by this. You have these programs. You can take a
the screenshot of this, which is connected on which, that is pin numbers. This is the same explanation. Pin number this is connected to pin number that. And this is your circuit diagram, how the pins are connected. If you have any queries related to this, you can ask for this practical. Prem is asking, power will be 5 volt. Yes, Prem, the power will be 5 voltage because this is the pin number 2. If you see the pin out which I have shown you in the command, pin number 2 is 5 voltage. Check. So automatically this particular, when I'll be connecting pin number 2, it is going to get connected onto that. So pin number 2 is this here, this red line in your screens will be connected to that, as pin out itself is 5 voltage. Is it okay? I hope you have taken the screenshots of this practical as well. So fourth practical, that was 8 cross 8 LEDs, is completed. Now the remaining two, I'll be showing you the execution first and then you would take the screenshots, or should I explain first and then show the outputs? Even this you had completed, so you can take up the screenshots for this as well. The fifth practical, that was your camera modules. The previous slide I had skipped quickly because it is common to every kit, so hence I'm not giving you the same screens. This is specification of the camera. What features does the camera board has? How would you connect the camera module? Take the screenshots of this. From where you will get this particular module again. These are your commands for still capturings, just the image via commands. So either through commands also you can do it, or using Python code. This is your Python code for images. Camera underscore still image. This is for recording a video.
The default player is Omax player, as I mentioned, MX player's version, OMX player, or you can even install VLC and view the audio or video. And the extension, default extension was H264. This was explained to you again in your theory when camera module was taken. So as of now, you people have taken the screenshots of first five practicals, and all those five practicals are shown you in execution. Eighth practical and 10th practical, I'll show you the execution, then accordingly I'll show you the PPTs. So let's go back to your Raspberry Pi. Now for Node-RED to start, I need to start up the server. To start up the server in the Node-RED, I need to go in the Node-RED block. So I have to click on Node-RED. I'm inside this particular, and service is getting started. So this is what the service gets started, and I can execute Node-RED via this. So check why I am waiting. I want the server to completely start. Once if you do not wait for server to start, you're not going to get anything. Now check, the server has completely started and now it is in the stable mode. Now to let the server be running in the background, in the top when the server was starting, check the IP address. Either I can run using your IP address if you remember, or I can run using the local host, or I can run via your 12.0.0.1 colon 1880. 1880 is the default port number for execution. Now to get the area of console for executing your Node-RED, if you remember, I have to go into your browser and via one of your flows I have to connect it. So let's connect it via your IP address itself. So I have this IP address. I'm trying to connect using this. So either web browser is present, the icon is present over here, or you can go in the applications in the internet. You have Chromium web browser. This is your default web browser. The default search engine which is used in your Raspberry Pi is DuckDuckGo, not the Google engine. It is DuckDuckGo which is used. So the IP address that is there 192.168.137.27 colon 1880. The moment I type this and I press enter, Node-RED is automatically going to be loaded over here. So this has loaded your Node-RED and I have got the workspace area. Now in your left, if you see, these are your filter nodes which are being present: inject node, debug node, function nodes. And if you scroll down, I have shown you this full list of the things. Check, you have dashboard nodes, your Raspberry Pi in and outs, your Twitter handlers also present over here, MQTT. Check MQTT in HTTP. We have seen all these protocols. So these all are present over here. Different tabs are present for execution. So these are your different filter nodes which are present over here. The common ones are over here. We have seen inject, debug, and print. This is your flow. If you want to change the name of the flow, just double click, you will get this. Say suppose I'm giving, this is our practical 8th, I suppose. So practical 8, when you click on done, automatically name of the node gets changed. This is the debug window where you're going to get the output of your display messages. So for example, I require an inject node. I'll click and I'll drag and bring. Check, the moment I bought over here, it is timestamp.
This is your output node. So whatever output, so input is there, that is going to be displayed onto the output in the debug window. The by default the object was message.flow payload. For connecting, I need to just click and drag and connect this. So that flow is ready. When I double click on this flow, check what the flow is showing me. It is showing me the properties. Timestamp is this. Do I have to repeat this? If I click on repeat, I will get the interval every 1 second. So automatically it is going to be repeated after 1 second. If I want to have a time, say morning 6 o'clock to 6:10, the alarm clock, as the alarm clock wakes, I need every minute it should give me on which days. So it gives you between time. So time clock you can set it up over here at a specific time. So scheduling of your laptops or installation of your data or retrieving of your data from your external nodes, you can specify the interval time or the specific times. If you put up none, it is not repetitive. If you make it as interval, if it is going to be in an infinite loop, you have to manually stop it. So let's put up non-repetitive mode for time being. So until unless I do not trigger it, it is not going to be automatically displaying the output. Once I click on OK, and I have to, for execution, I have to click on deploy. Once I click on deploy and it is successful, then only check this trigger will be activated. This is a button because it is not configured for the trigger automatically. So when I click, it is generating some number. And this number is the number of seconds of your time, the timestamp, the actual time. When I'm clicking on this, check, selecting this, it is highlighting the message.payload. This is the number, and this number is nothing but in seconds the time. If you convert the date and time in seconds, you're going to get this today's date and time. In case if I do not want this, it should get repeated automatically. I'm changing the interval, say every 2 seconds it should change. So I'm clicking on OK every 2 seconds, but it is not displaying, it is not coming because I haven't deployed it. So for saving and executing, I need to click on deploy. Once I do that, check at this time 33, 35, 37, every 2 seconds it is displaying the outputs. Can you see the timestamp every 2 seconds? Now this is an infinite loop. For this to stop, I have to disable the flow. Is it clear? Now this was a number which was very now check, I have changed the flow, it has stopped. After this, it is not moving. From 3 to 12 seconds, I have completely put up. In case if I have to put up my function, now everyone has done your JavaScripts, is it? You're well known with your JavaScript. So I'm going to write down a JavaScript program inside this function. So I have writing down, say, the name of the function is this. Now in the function, the output has to be redirected to your message.flow. I want to generate a random number. So this is how your random number is generated in your JavaScript, math.random. Now by default, the random is going to give you the random number between 0 and 1. So I'm multiplying with 100 because I want to make that as a 3-digit number between 1 and 100. It could be decimal also. So I'm just using the math.round function. So this is your basic JavaScript that I'm doing, nothing else. So JavaScript editor is on, and in that I'm typing down this. So code is written and I'm returning the message. I'm clicking on done. So the command is written and the function is ready. Once it is done, I'm trying to connect the timestamp. So timestamp is going to invoke the JavaScript function, and whatever the random number is generated, I'm going to give it to the message.payload. So if you see over here, I have cleared the debug screen and I'm deploying the things. So once it is successfully deployed and I click on trigger, trigger has generated on time some random number is being picked up and it is printing. So when I keep on doing. I have some random numbers between 1 to 100. So whatever function you write down over here, it is going to give you. Similarly, instead of JavaScript function, you can even have your Python functions, user defined functions. Is it okay? The Node-RED. Now the aim of the practical is for Node-RED. Check whatever flows we were doing. It was starting and stopping. It was taking care of each and every nodes. So let's see your aim of your practical and then we'll move ahead. So the aim of your Node-RED is, that is your eighth practical, serial number 8 in your syllabus. Hence, I'm not changing the numbers. Prahlad Chukla, why you're punching the PRNs? I haven't asked you. So now I can dismiss you because you have already given your attendance and you were waiting only for the attendance, I suppose. This is your basic connections. You can take these screenshots while explanation only for this practical. So take up the screenshot of the aim of the code, aim of the practical, that is 8th practical, Node-RED, connect LED to your Internet of Things. Again, I'll require this basic configuration, extra components apart from your basic ones. Click the screenshot for this. This is how you're going to switch on your Node-RED. Just now I have shown you. Click on programming, click on Node-RED. This will start up your server. So once the server is started, you can move onto your browser for execution of your Node-RED. This is how we have switched on your browsers. Yes, you have to take the screenshots right now itself. Hence, I'm waiting and giving you the explanation. Because this I have already shown you.